So let's just go through how we can look in the brain. You know, at one time when we used to do studies on the brain, the only opportunity we had to do studies is one when someone was injured, and we got to see where the injury was, and then we'd do kind of little tests, ask them questions and see if the injury affected how they think, feel, and behave. Then what we used to do, if anybody had any open brain surgeries, I know this sounds gross, but when you have a tumor removed a lot of times and they have to open up your skull, there really aren't a lot of pain receptors up there. So what winds up happening, they put you on a mild sedative, they open you up, and they love to do research when that happens because they'll poke around up there and then ask you questions. But we don't have to do that anymore because we have all kinds of wonderful little ways to look in the brain. CT scan is a computed tomography scan. You've done these before, maybe on your ankles and your knees. What they are, enhanced x-rays, and we can take a look at your brain that way. MRI scans, magnetic resonance imaging, 3D pictures of your brain and what goes on in your brain. One of the more interesting ones is called a PET scan, positron emission tomography. We can actually look at brain activities and actually record what you're thinking, not what you're thinking, but what areas of your brain are active right now. Okay? And what's interesting about this is that you would think, I guess rule of thumb would be the more intelligent you are, the more your brain you use. But in actuality, the more intelligent you are, the more efficient your brain usage is. Like if somebody is really, really good at math, some of you are good at math, I can throw numbers out and you do numbers in your head. Well, when we look at that person doing math that way, very small parts of their brain are being used because they do it so quickly. Those of you who just can't do math, I just don't have a brain for math, you might say, when I give you a problem to do, a lot of your brain lights up because you're kind of like, I don't know how to do this. And you're trying to search for your answers, so it really begins to light up that way. When you have different emotions, okay, I can look at your PET scan and probably determine which emotion you're having just by looking at the PET scan and then asking you, because there's all kinds of research on this as well. The one psychologists use the most is a functional MRI, which is kind of a combination between a PET scan and an MRI. Records brain activity as well. These are all extremely expensive to use, okay? And there is, if you ever really get interested in this, UTD has a brain health center over on Love Field on Mockingbird, and they're always looking for volunteers to go in there and get under their functional MRI. So sometimes you can go there and volunteer and just check out what they're doing. If you ever go to UTD and you're in psychology, you can probably volunteer to work down there as well. But they're, I think, the only one in Dallas that has a functional MRI. Just to show you what a PET scan looks like, when you ask someone to try to solve a problem, you have two different activities going on here. The more vivid the colors, okay, the more vivid the colors, the more the activity there is. So whatever problem this was that we gave to this person in the back of their brain, it kind of lights up as they're trying to search the answer. This person over here is using more of their brain to look for the answers, but it's not as vivid as the hot spots that are in there. Okay? Just to show you that. I ran across this study where they've actually asked people, we're going to give you 10 questions. Don't tell us which ones you're lying on, but I want you to lie on 5 different questions because we want to map your brain as you're lying. And they actually have a map of the brain that'll depict when people are lying. Here are the hot spots that begin to open up in different parts of the brain. This would be interesting to have. Wouldn't this be great if you're trying to figure out your boyfriend, girlfriend, husband, wife, if they're lying to you or not? You can just ask them. Who knows? Maybe some days that we'll be going through the airport and they'll scan our body for metal and things like that, but maybe they'll just do a quick scan this way on us and ask you a couple of quick questions to see if you're lying or not. I don't know what's going on, and maybe this will be admissible in courts someday. But they can do this stuff. They do have this information to find out how your brain is processing information. All right, so let's talk more about the brain. We'll do this for the whole class today. The brain is made up of two large hemispheres. All right, the cerebrum, cerebral cortex it's also called. Okay, it's all this gray matter that's up here. All right, the cerebrum, cerebral cortex, cerebral hemispheres make up two large hemispheres that cover this upper portion of your brain. All right, so there's a left hemisphere and a right hemisphere. Two distinct parts of your cerebral cortex, also called the cerebrum. All this material is up here. If we were able to look inside there right now, what I told you the other day, it looked like there was a huge thunderstorm going on, all kinds of electrical activity going on with all kinds of chemicals being released in your brain. The cerebral hemispheres, left and the right, actually control the opposite sides of the body. It's kind of interesting. All right? So when I want my right arm to move, it's my left hemisphere that's going to tell my right arm to move. When my left arm moves, the right hemisphere is going to tell the left arm to move. If I had a stroke, hope I never have one, but if I did, and it was damage to the left part of my brain, what will happen, there'll be damage to the right part of my body, whether that be my hearing, my sight, my arms, my legs, or anything like that. Connecting the two hemispheres is something called the corpus callosum, and it's connecting fibers that keep these two hemispheres together. So anything that your right field of vision or your left field of vision brings into your brain is then shared with the other hemisphere. So let me tell you a story. Back in the 1950s and 60s, okay, there were people who had epilepsy. I don't know if you know what epilepsy is. Okay, real simply, real basic, what epilepsy is a malfunction in the brain which increases the electrical charge in the brain. Okay, so there's actually a charge that occurs in the brain. Now, we have two types of epilepsy. One is called grand mal epilepsy, and when these people have a seizure, they're called grand mal seizures, which are very, very severe. There's also something called a petit mal seizure, which are minor seizures. Well, back in the 1950s and 60s, we had medicine for petit mal seizures that basically kept it in place and reduced the output of it. But we didn't have any medication for grand mal seizures. And what we told these people was, I'm sorry, we really can't treat it. If you have too many of these, okay, that could overwhelm your brain and shut down basic functioning, and you could die. Not a pleasant sight, right, to hear that in any way. So there was a man by the name of Sperry, and he received the Nobel Prize for doing this research. But he was trying to determine, could there be a way we could reduce the output, okay, the kinetic energy of this type of grand mal seizure. So what he figured out was that there's a malfunction, let's say in a part of your brain, let's say right here. There's a malfunction that's there. And what the malfunction does is increase the electrical charge. So what happens is that there's an overwhelming electrical charge. Remember the other day, it goes from one neuron to the next. And what happens in this is that the wiring there can't handle the charge. And it goes back and forth, 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 until it can't handle the charge anymore. Boom! And there's a major grand mal seizure that occurs. Everybody got that? So they're working with medication, and Sperry, by the way, was a physiologist. He was not a neurosurgeon in any way. And they couldn't figure out any medicine, so he said, I wonder if there's a way I can short circuit, okay, this charge so it doesn't keep building up, building up, building up. And he thought, how about if I go in and cut the corpus callosum? Therefore, when there's a charge here, as it starts building up, it can't go across the brain and get over here, and maybe that'll diminish the charge, make it a petit mal seizure, and we have medicine for that. Well, when you do research like this, the first thing you start off with is a little mice, then you go to rats, And people don't realize they're not, but the next animal they usually go to is a cat, okay? Because cats' brains are very similar to humans' brains, okay? Not that they're intelligent beings. I know your cat is. I know that. Okay, but so he did all the research, and it worked on mice, worked on rats. He did it with cats, and it worked on cats as well. Wow, pretty interesting. He then published his results in a major journal, and it got a lot of publicity. Okay, and he got into the newspapers, and then he started having people call him. Who called him? Well, people who had grand mal seizures. And said, you know what, I've been told I could die if I have too many of these. I'm volunteering, do me next. Okay? And Sperry went, whoa, that's a big jump going from cats. Usually we go to chimps from here. I don't think I'm going to do humans. And they said, hey, I may die if you don't do this for me. So we had a little bit of what we call an ethical dilemma. You know, can I help people or not help people? But he went, I don't work on humans. Well, there were quite a few neurologists, okay, who got together with the neurosurgeons who went to Sperry and said, let me see how you do this. Sperry trained them how to do it on cats. And so they said, well, let's give it a try. You're absolutely right. These people may die. Let's try. With their permission, they went in and cut the corpus callosum so the charge couldn't go across, and it worked in humans. Petite mal seizures, control it, it worked. Incredible work. But there were some side effects of this. Okay? As people went out in the world, they started doing stuff in their lives, and there was one, I think it's a funny story because I have a warped sense of humor, okay? But there was this lawyer who was back in the courtroom, okay? And he was defending this client that was there, and he was talking to the jury. Make sure I do this right. He was talking to the jury. Okay? And what happened as he was talking, he was gesturing. Let me tell you, my client is innocent for this reason and this reason only. And he didn't know this, okay? But his left hand reached up as he was talking, undid his tie. Okay? Now, let me tell you why they're so innocent. Started undoing his, and I can't even do this, okay? Because my brain is connected, and I know what I'm doing, but it started unbuttoning his shirt, went down to his belt buckle. I'm not going to do that. Undid his belt buckle, and then went down and actually did his button. He was about ready to unzip her, okay? And the judge went, whoa! She said, wait a minute. It was a she. She said, wait a minute. She said, what's going on here? I thought at first this was part of your defense, but what are you doing? He said, well, what are you talking about? And this hand was just kind of flopping around. And they said, well, look. And he looked down and he went, oh, I don't know. It was as if he actually had two brains up here. Okay? And one brain was controlling, right, what was going on here, and the other one was gesturing like this. They then went back to all of the people, okay, who had this surgery done and said, have you noticed anything strange going on? And they got flooded with material. One woman would say she'd get up every morning and think about what she wanted to wear, and her right hand would reach in and pull out one outfit, and then the other hand would reach in and pull something else out. And it usually was a weird, okay, combination of clothes that would come out that were there. And these people were all reporting this stuff. Then they started doing research on this and actually found that there seems to be two different brains that are there functioning in different ways, called a split brain. This is called split brain research. And then what they found out is that the left and right brain may actually control different types of activities. The left brain seems to be the basis for language, controls language and verbal abilities, speech, seems to handle the writing, calculations, time sense, your sense of rhythm. It has a lot to do with order, a lot of ordering, logic, rationality. This brain does better in algebra, okay? The right brain seems to be more nonverbal, perceptual, visual, seems to do better in geometry, not algebra. Some of you love geometry, but you hated algebra, and vice versa. There are really two different ways you do math if you've taken both of those subjects that's there. When people did further research, they came up with and said, you know, left brain people okay, seem to be more analytical, research-based, scientific, logical. And right brain people seem to be more creative, artistic, nonverbal. And they started doing more and more research, and they said, well, it looks like there could be differences. Then they started saying, I wonder if there's a difference between left-handed people and right-handed people. And what they found was that there are more left-handed people than there should be statistically in the artistic fields. Okay? Which may mean what's happening. I'm using my left hand a lot because I'm a left-hander. Maybe I'm getting more blood and oxygen up to this brain over here, and it makes it more efficient, more well-developed than this brain. Maybe that's what it's about. Okay? At one time, they used to tell people, let's see if we can teach children through what's called whole brain education. And some of you may have been in the 70s in school. Nah, probably not in the 70s. Okay, some of you who are older were in the 70s in school. And they used to actually try to get you to use both hands when you write. They have exercises like this every morning. And then switch it like that. Have you do this, have you do that, to try to exercise different parts of your brain, play music, okay, as you do math. Didn't really work that well. Why didn't it work that well? Because most of us have not had our corpus callosum cut. Okay? If your corpus callosum is intact, then information is constantly shared with both hemispheres. Now, if you are left-handed, are you more creative, more musical, and on and on? Well, some of the research says, yeah, there's a lot of research there. Is that because of brain development, or is it because people always treat you very differently anyway? Right? You left-handed people, okay? And the right like this. And what happens when you sit down at a dining table? They usually stick you on the end, okay? And you got to buy left-handed scissors. So maybe it's because you're treated differently. Could a cut mean a corpus callosum person who's had a cut has what syndrome?
Autonomous hand syndrome.
Which means?
It's basically what you were describing, where one hand does something that they're not.
The other hand doesn't. Well, that's what they would have, right? It's what they would have with that, but the people who have that disorder do have their brains intact, the corpus callosum intact. And I really don't know enough about that. It just may be that, again, the functioning is very different that's there. It's interesting material, isn't it? At the end of your chapter, they have this little application part that's there that asks you if you want to take that to see if you're more right brain dominated or left brain dominated, analytical, logical, or more creative. Well, back in the 70s and 80s, they were trying to train people to do that, okay? So if you're ambidextrous, okay, that's pretty good because you're getting blood and oxygen in both parts of your brain. That's there. Here's another interesting situation which we've noticed is that there are more left-handed people who have dyslexia, okay, than right-handed people in terms of percentages that are there. Dyslexia, again, is a disorder in terms of language acquisition. Okay? There's also math dyslexia and all kinds of dyslexia. So where is that occurring? Language development is in the left brain. That's there, right-handed left brain. I don't know where to go with that. They just kind of had a correlation with that, right? No causation.
So it says opposite hemispheres of the brain control opposite sides of the body. Why would you spend time training the right-hand side of the brain? Like, if you're left-handed, your right-hand side of your brain is controlling your left hand, right? Like, why would you spend all this time training the right hand?
That's what I asked in the 1970s, and I said, why are we doing this? Because the research is only on people who had split brain research done on them. Why would you wind up doing that? And their answer was, well, if we can get blood and oxygen to both parts of the brain, okay, then maybe we can make both of them, okay, more substantial, more robust, okay, and therefore helping the transmission of that information.
So even if you're like, okay, so I'm right-handed, but I feel like I'm more creative and not very left brain side.
Yeah.
It doesn't matter what side of your brain, like left hand or right hand, just
And your creativity is probably genetically predisposed, and then you worked on it when you were younger. You know, what they say is that most of this research is not 100%, right? That's there. So we find the majority of right-handed people, okay, seem to be more logical and rational, and not a majority of left-handed people, but a higher percentage than we think should be of left-handed people are more creative. But you're creative, right? I think we're all creative. In some way, we need to find that. That's it. Probably your pursuit of creativity probably happened when you were younger. It was just fun to do this stuff. And the more you did it, the more interested you got, the more you developed that part of the brain. I guess we can hook you up to a PET scan and we'll see what goes on. No, okay. No PET scans for you. All right, let's talk about the different lobes of the brain. I'll show you a picture. Lobes of the cerebral cortex, right? This big lump that's up here. This is in your book, but you might want to just write down. I'm just going to do the 4 main lobes of the brain. Your book mentions more lobes than this. Once again, the first picture I showed you the other day, I'm just going to give you a generality of what the frontal lobe controls. However, remember the other day I said, well, this section controls one thing, this something else, this something else. That's way beyond the scope of this class. So I'm just going to give you a general idea that different parts of your brain, okay, control different aspects. Damage to different parts of the brain can affect and effect how you think, feel, and behave. Development of different parts of the brain may indicate you're developing a particular skill that's there. The frontal lobes, I think, are the most important part up there, because the frontal lobes, this big part right here, sense of smell, motor control, and here it is, higher mental abilities, such as reasoning and planning. This is the last part of your brain that develops. The research says your brain is not fully developed, are you ready for this, until your mid-20s. Your brain is still developing. The last part of your brain to develop is the seat of mental abilities like reasoning, planning, decision-making. When you were 14 years old and you came home and your mom said to you, "What were you thinking? Why did you do that?" And you said, "I don't know what I was thinking." That was probably a pretty good answer, because your brain may not have been fully developed to make good decisions. What's fully developed in an adolescent's brain is over here, the temporal lobes, which is for hearing and language, but it's also the seat of emotions. And a lot of adolescent decision-making is based on emotions. If it feels good, do it. Okay? If my friends are doing this, I'll do it. All right? A lot of dumb decisions that go on, but part of it is your brain just isn't well developed just yet. Not until our mid-20s is it fully developed from an anatomy perspective. Those of you into science fiction, if you ever see creatures from other planets who come down here, we usually think they're smarter than we are. So if you look at their skulls, usually the people depict them as having big foreheads, because they think this part of the brain must make them smarter, so they have bigger parts. Remember E.T. and some of those characters always had big foreheads that were there. Frontal lobes. Parietal lobes right back here, sensations such as touch, temperature, and pressure. Occipital lobes in the very back. One thing it controls is vision. If you ever get smacked in the back of your head, it could interfere with your vision. And what happens? You wind up seeing stars. Get smacked back here. Temporal lobes, hearing and language, get smacked on the side of the head. We say sometimes you got your bell rung, because you actually hear, okay, sounds like a bell, because it interferes in the processing of what you hear. Different lobes of the brain to determine how you think, feel, and behave. All right, the cerebellum I'm going to cover next. I'll do that right now, because on the next slide it says cerebellum. I'll just show you that. Okay, we're going to talk about the hindbrain back here. So the first thing is the cerebellum. So I'll put it back up. Cerebellum controls posture, coordination, muscle tone, and memory of skills and habits. So it's really neuromotor memories that are there. Research is beginning to indicate to us that people who are extremely well coordinated, maybe some gifted athletes like gymnasts who have incredible what? Body posture and balance, muscle tone that's there, they seem to have a more efficient cerebellum, okay? More developed. Maybe they have a genetic predisposition. Parents pick up on that, and then what happens? They then have them train, which, just like any other muscle, then develops those connections that are there. Those of you who are just clumsy all the time, you've always been clumsy, well, probably you don't have a very well-developed cerebellum. That's there. When you were adolescents and your body went through those growth spurts, your neuromuscular control did not keep up. This part of your brain was trying to keep up, and you were very clumsy, and you'd knock things over sometimes. The cerebellum. Recognize I'm also bringing up a point that says that some of the incredible abilities some people have could be brain-based and developed through genetics, okay, or brain structure, and then biopsychosocial, the psycho part, habitual, working at something till it became a habit. The next thing we want to talk about is it's this. Exactly what I'm doing right now. The reticular formation helps you to stay awake, alert, and the key word is pay attention. The reticular formation is buried deep in the brain. Let me just show you quickly and I'll come back. The reticular system formation is way back here, and when it gets a message from the environment that said, look out, something is not right, anything that's new, different, odd, scary, threatening to you, when the reticular system gets the message from the brain and from the senses, and it says, oh, we need to watch out for that, it sends a message to all parts of the brain to pay attention. Pay attention. You with me? Because what happens sitting in this class, sometimes your reticular system goes, oh, well, nothing dangerous here, just some guy in the front talking. Okay, no big thing. But as soon as the door opens up, your brain goes, who's that? And everybody looks over there, right? I mean, I see this all the time. I'm talking to you, door opens up, everybody does this, and they come back. If there's an attractive woman or an attractive guy going behind me, I see the eyes going. Okay. And your brain right now is going, pay attention to her or to him. Because that's what it does. It makes you pay attention. This part of the brain, the frontal lobes, you can train to control the reticular system. And all of us grew up with media, and what media does to us is only pay attention to things that are loud, noisy, things that are blown up, changes in music and everything else. When you people sit down, you watch some movie that has a lot of talking in it, like a lot of these English movies seem to have a lot of talking in it, or the movies from the 1940s, 50s, and early 60s. God, when are they going to get to the action? Movies nowadays, attention spans are real short. So what do? Have a little dialogue, boom, something gets blown up, or music changes. And what your brain does is go, oh, there was a change, pay attention to this. And it brings you in. That makes my job very hard because your brain is trained not to pay attention. All right? How about this as an example? New baby in the other room. 10 new babies in the other room. 10 moms right here. One baby cries, one mother wakes up. Why? Because she's trained her reticular system through senses and everything. When my baby cries, that's my baby's cry, and only one mom wakes up. Pretty interesting research with that, if they're a good mother and they're connected to the child. Sometimes that doesn't happen. It's part of that bonding process there. Here's another one. Mom and dad, mom and partner, whoever it is, laying in bed together. Baby in the other room. Baby, sound comes into the room. Mom wakes up, dad sleeps through the whole thing. Anybody had a baby and have a spouse and that happens? That sure happens. My wife used to go, it's your turn to get up. Wake up. What do you mean? What winds up happening, Mama says, sudden infant death syndrome. I'm afraid for my baby. I hope if she's talking to herself, if the baby turns around the wrong way, if there's a breathing, I want to wake up. I want to be there with my baby. She has given herself a conscious suggestion to tell the reticular system to be on guard. Just pay attention, pay attention. Dad probably said, she'll wake up if the baby cries. Go to sleep. And we told our system, don't bother with that. You can train this. When we get to the chapter on sensation and perception, which will be the first week in October, I believe, I'm going to do a little session with you on trying to get you to focus and keep the reticular system and your other sensory system to stay with me. It's an incredible skill to have to focus. If you're a good athlete and you're successful, you've learned to focus. I watched that tennis match on Monday, okay, and Rafael Nadal has an incredible ability to focus on every single point. It's amazing how he can do that, okay? I mean, I'm talking to you and I'm also thinking about something else, okay? It's just so hard just to focus your brain like that. You're with me, though, now, aren't you? Okay, stay with me. So he didn't know he was part of a psychological experiment. All right, now we want to look at the forebrain. Okay, what parts of the forebrain? One part of the forebrain is called the thalamus. Okay, and I'll show you a picture of this after I talk a little bit about this, but the thalamus is buried deep in the brain, very deep in the brain. And what does the thalamus control? It has a lot to do with memories. Memories. It's one of the last spots before things get sent off into your memory circuits where information goes. That's all I'm going to say about it, memory. Because when we get to the chapter on memory, we'll talk more about the thalamus. Damage to this area may hinder people's ability to bring back long-term memory and or short-term memory. The hypothalamus, hypo means under, it's underneath the thalamus. It's about the size of a little almond. That's all. It's real small. Okay? But boy, does it manage a lot of parts of how we think, feel, and behave. It's the seat of hunger and also satiation when you're full. When you get hungry, this part activates your stomach lining. It has a feedback loop with your stomach and sugar levels and on and on. It's what says hungry, hungry, hungry. It also says full, full, full. It's also an area that controls thirst, thirsty, 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 no longer thirsty. It's also the center of some of your pleasure zones. Okay? So when you're doing something, what you're doing makes you feel good, you're shopping, and it's like, I like shopping, and you feel good while shopping, okay? There's a part of the hypothalamus that gets lit up that then tells the brain to release certain neurochemicals to make you feel better. When you're engaging in very pleasurable experiences, whatever they may be, the hypothalamus gets engaged. When you're having sex with your favorite person, okay, and it's feeling really, really good, okay, and you might even have an orgasm, okay, the hypothalamus gets activated. Wow! It just lights up like, woo, this is good. Okay? Maybe someday we'll be able to put a little electrode in there, and when you go out with somebody, you go, hi, I'm Steve Link. Zip. And they go, woo, wow. I'd like to be with you. All right? I mean, you never know where we may be going with this in the future. Hypothalamus controls an awful lot. It's also considered to be the master of the master gland. The master gland is usually the pituitary gland, and I'll get to that in a second. But the hypothalamus actually tells the pituitary gland to release certain things. So hypothalamus, really, really important in psychology. The next one you want to talk about is the limbic system. Limbic system, not Olympics, but the limbic system is the seat of emotions, is the place where emotions are engaged. All right, so let me show you all this now. Emotional controls emotions. So as we look at this, there's the hypothalamus, there's the thalamus here, hypothalamus here. This whole thing is called the limbic system, all of this. Hippocampus also has a lot to do with memory as well. Okay? Seats of emotions. This little part right here called the amygdala, okay, is the seat of aggressive behavior and frustration. It gets lit up when you get angry and upset. There was a psychologist by the name of Delgado. I still remember his name. He did this really interesting study where he implanted an electrode in a bull, B-U-L-L, a bull's brain, got into a bull ring with him, and the bull was on the other side of the ring, and he had one transmitter here and another transmitter here. This transmitter activated the bull's amygdala and made him angry. Zapped him on. He just saw the bull just go, and look around, and Delgado was at the other end of the bull ring waving the cape and going, "Hello, I'm over here." Zapped him again. And the bull comes charging after him. And Delgado throws down the cape, stands there like this, pushes the other button, and I'm not going to get into it, activates a different part of his limbic system to calm him down and make him feel good. And you saw this bull all of a sudden go, and stop, snort a couple of times, and just kind of walk away. And I did it again to him again. Comes charging. I'm glad he got the buttons right. Right? He'd be in tough shape. That's the interesting stuff. I don't know. Maybe some of you, hopefully no one in here, who has a tendency to be very, very angry, like you need anger control sessions or anger management sessions because you get angry all the time, just a short fuse. Maybe there's something going on in that area right there. All right? I'm beginning to hear, people in a trial situation beginning to say, well, maybe it was my amygdala that made me do this and stuff. There's not enough research for lawyers to pick this up and make it presentable just yet. My guess in the future, those lawyers will pick up on something that's there. This also might be interesting. Maybe we can treat people who have a tendency for violent crimes if this does do this. Biopsychosocial then says it's not just this, though, right? There are other things that go on in people's lives that make people violent. But this could be it. And as you go through this, there are different parts in here that are seats of happiness and sadness and everything else. Maybe those of you who are very, very emotional, by the way, the limbic system, if you see this over here in the temporal lobes, maybe those of you who are very emotional have a very well-wired limbic system, and you just react to things more because you have a very well-developed, efficient emotional system that's there. You're just emotional. That's all. So when someone says, "Why are you crying? It's a movie." You're like, "Because I'm just emotional." Dr. Link said it's just my brain. Okay. Just some people are. Some people may not be. It could be what? Brain. Or maybe it's what? The psycho part, modeling, cultural perspectives, big boys don't cry. Maybe it's all kinds of different things that we were taught. But in this chapter, we're just talking about the brain. All right. Another part of the brain that controls how we think, feel, and behave is the endocrine system, the hormone system. How hormones affect how we think, feel, and behave. The other day I talked about estrogen, progesterone, and in particular testosterone in men, and about how those hormones may affect how you think, feel, and behave. In particular, I said for men, testosterone also makes a man more aggressive, but it also increases his sex drive. By the way, women who have high T counts, high testosterone counts, do have a stronger sex drive. Right? Do have a stronger sex drive. All right, so we looked at that. That's there. Now let's look at these 4 different glands. So I'm going to cover each gland, but let me show you a picture, because it also has, next to the picture, it has what it controls. So the first one on our list was the pituitary gland. Located deep inside your brain, influences growth, lactation, also regulates the activity of other glands. Tells the other glands what to do. Has a lot to do with growth as well. Some of you, when you hit puberty, you didn't grow very much. You were way behind in 8th and 9th grade. Your mom or dad took you to the family physician, and they may have put you on some type of pituitary activating hormones to try to get that growth spurt going. That's all I want to say about that. The next one on your list, I believe, was the thyroid gland. Now, the thyroid gland, believe it or not, has a lot to do with psychology and how you feel. The thyroid gland regulates the rate of the metabolic rates of your body. What are the metabolic rates of your body? How much energy do you produce to burn off calories? You get that? The thyroid gland is going to produce energy. Okay, it gives you that burst of energy, that energy you have to do things. Okay, and it helps you burn off calories. Now, as a practicing therapist, if I have somebody come into me and say, "Oh, Dr. Link, I was referred to you by so-and-so. I'm going to tell you, I'm just really depressed. I have no energy whatsoever. I don't want to get up in the morning. Everything looks bad to me." One of the first things I'm going to ask them, and everybody goes, "What are you talking about?" is I'm going to ask them, "Have you seen your family physician yet?" Why? Well, I would like to help you. However, if there's something physical going on, why talk about your life and what's going on if it's something maybe as, and this is not simple, but I'll say it, simple as having an underactive thyroid. Okay? A hypo-hypothyroidism. What that happens is people just don't have energy. You're not producing enough thyroxine. You feel very lethargic. You're tired all the time. You have no energy to do anything. You just sit around and you feel depressed. The symptoms of someone who has an underactive thyroid are very similar towards depression. But the key here is that these people can look at food and gain weight. Okay? Why? They're not producing enough thyroxine to burn off calories. So what happens is that they just look at food and they start gaining weight. There are some people who are overweight, and the only reason why they're overweight is because they have an underactive thyroid. That's there. Women, I think none of you are premenopausal, but when you get in your late 40s and into your 50s, as your body starts changing hormonally, your thyroid also begins to change. And there's a correlation with premenopause and menopause and an underactive thyroid, which then sometimes we say, oh, menopausal women have a tendency to be depressed. Well, yeah, it could be because of levels of estrogen and progesterone changing, but it also may be because of the thyroid that's doing this to people as well. Okay, so we get that checked out. Now, the opposite of this that psychologists also look at, if someone comes in and says, you know, I've been referred to you because I just can't relax. I just can't. I can't sleep at night. I'm just always going. And something else is really weird. I just eat all the time and I still gain weight. Well, this is the opposite. This is called hyperthyroidism. That's there. Your body is just buzzing along all the time. You're producing too much thyroxine, okay? And then you're producing too much cortisol, and you're just buzzing along. It's like you're stressed all the time. These are the people that some of you who have to watch your weight are really envious of, Because these people get up in the morning, have a big breakfast. Around 10 o'clock, they have another breakfast. And then you go to lunch with them, they eat their lunch, and they look at your plate and go, "You going to finish that?" Okay, and they eat everything on your plate. And they never gain weight. Okay. By the way, this is, for some of you, that was what adolescence was about. Because when you were adolescents, your brain was just buzzing along, looking for calories. Because it was just expanding. Okay, and you were just eating. Okay, as a parent of 2 former adolescents, my wife and I said, "God, our grocery bill is outrageous. These kids are just eating all the time." And some of you have adolescents are going, "Yeah." Okay, they just eat. Calories, 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 and they burn it all off. But then you hit your 20s, okay, and your body isn't burning it off as much, but you still have the old eating habits. Okay, and you start gaining weight very quickly. Thyroid gland. It's pretty interesting, isn't it? As an indicator of how we think, feel, and behave. The next one on your list was the adrenal glands. Secrete hormones that arouse the body. Remember we talked about fight or flight? The sympathetic part of your nervous system, adrenal gland, boom, begins to release adrenaline. That also is, come see me, you're too anxious, let's go get a good physical. Maybe you have an overproductive adrenal gland, a malfunctioning adrenal gland that makes you feel so anxious. Let's check that out first before we talk about your life. Then the last one is the pineal gland, helps regulate body rhythms and sleep cycles. Pineal gland produces melatonin. So most of us have a sleep cycle. The other day I was talking with you about gut intestines and serotonin levels, right? Didn't I do that the other day? Well, the other fascinating thing for me, the more and more I read about, is sleep cycles. About how people, if they don't get into a cycle and get enough sleep, it's correlated with depression, it's correlated with stresses. Too much stress as well, because you're too stressed and you can't sleep. Impaired judgment. New fields that are going on just saying how important sleep cycles are in sleep. Well, most of us are on a sleep cycle. At a certain time at night, you begin to get sleepy. Okay? So let's make believe you go to bed around 10 o'clock every night. It's probably early for most of you, but let's say 10 o'clock. Well, around 8:30 or 9 o'clock, your pineal gland is going to begin to produce melatonin to start making you kind of sleepy. The pineal gland is also, associated with light. The darker it gets, the more melatonin is going to be released. You get that? The darker, so it's what? Nighttime has occurred, it's 9 o'clock at night, sleep cycle kicks in, you start getting tired, you go to sleep. Then about an hour before you usually wake up, or an hour before sunlight comes up, the pineal gland begins to decrease the production of melatonin and you begin to wake up. How is this related to psychology? Something called seasonal affective depression. What does that mean? That's when you live in an area of the world that doesn't get a lot of light in the winter. Okay? Or if you live in Seattle in January, February, or Alaska, the Scandinavian countries, any place north or south where they get very little light. They get a lot of this. Okay? What happens is people just start getting depressed. I would too, for psychological reasons, if it's dark all the time. What happens to us in bright, sunny Texas, right? When we have 3 days of rain. It's dark again. What's the deal here? We start feeling down. It could be for psychological, but maybe too much melatonin is being produced. What's the treatment for seasonal affective depression? Do you go sit down with a psychologist and talk about your childhood? No. What you do is you sit under lights, certain special lights, and when you usually get up in the morning, you sit under the lights, which decreases the release of melatonin. So there's all kinds of reasons why we think, feel, and behave. A lot of them may have to do with what? What goes on in the brain.
What about things like jet lag?
And jet lag fits right into this. In fact, we'll talk about jet lag in another chapter, but it's all part of this. That's why they say sometimes some people take melatonin as to help with jet lag at certain times to get you to sleep and stuff. And there's some research that it helps. Flight attendants swear by it. They use a lot of that, and it seems to help them with that. But yeah, that fits right into jet lag because you're interrupting these cycles that are there. And people who get their cycles interrupted, like people who do switch shifts all the time, they have high rates of depression, anxiety, accidents, drug addiction. Their cycles are just so messed up. Somebody.
If you overtake melatonin, will it stop your natural process?
Yes. Yeah. Overtake anything. Okay, it'll stop the natural production of those. Right?
It's just like recommended for like the ones that
Right. And especially if you have like a sleep disorder and you're under prescriptive care, one of the reasons you might have a sleep disorder is you're not producing enough on your own anyway. So then they give you this to help you. Right. The people who do this, like flight attendants and stuff, who take melatonin for overseas trips, they don't do it every day. They just do it a couple of days before they're supposed to go. And I forget what the cycle is that they use it for. But it's for short periods of time. A lot of medications are great for short periods of time. Let's see if you were listening. For 1 point. Overactivity of what gland leads to tenseness and excitability? The thymus, the thyroid, the hormone, or the serotonin? Now, what's the key words here? Tenseness and excitability, right? So now we're thinking back, what gland did he talk about that produces tenseness and excitability? Could be a couple of ones, right? In there. But there's another key word in here. Well, overactive, but that's important. But gland is another one, right? Because you're looking for a gland. And if you've been paying attention, these aren't all glands up here. Did you get that? Let me tell you what happens take a multiple choice test. Some of you put yourself, I need to take this test as quick as I can. And you go through as quick as you can. And when you read these questions, sometimes you just skip over questions. You skip over the key terms looking for answers. There's only one right answer to this. I'll do this with you because I want you to pay attention. Once again, when you take a multiple choice question, do it slowly. Look at all the words in there. There's only one gland, isn't there? Those of you who figured that out already? Okay. Whether you know if it's the right gland or the incorrect gland, there's only one gland that's listed there. Change your answers quick. And if you have to change your answer because you just figured it out, then you're one of those people who look at multiple choice questions too quickly. You've got to look at all the words that are there to figure it out. All right, we got it? 1, 2, 3. All answers in? All right. So 99% of you are wrong. No, are right. It's the thyroid gland, right? Thymus. It's not a gland. Okay? But right, so you want to pay attention to that. Let's do another question. By the way, I just finished this chapter. So now I'm trying to give you questions to review for the chapter, right? In higher animals, visual portions of the brain are covered with a wrinkled layer of gray matter called the what? The cerebral cortex, the cerebellum, the corpus callosum, or the forebrain? Now, in my class yesterday, only 30-something% of the students got this one right. So when I was talking about this today, I added a lot more information. You see, this also helps me to check, it's a feedback loop here, to see if I'm explaining things correctly as well. In higher animals, visual portions of the brain are wrinkled layer of gray matter. So wrinkled layer gray matter are some of the key terms that are on there. Portions of the brain. This is a tricky question because I covered each one of these, didn't I? But visual portions of the brain. So somebody help me out. Let's help the class out with this. How are you thinking about this to come up with the correct answer? What were some other key ways to think about this? Portions, right? We're looking at large areas, maybe, not individual parts that are there. Visible portions. Some of you get this very quickly, and you're going, Steve, why are you doing this? Okay? Because other people don't. Some people just don't know how to take multiple choice questions. And I talk with a lot of you, and you go, well, I knew that answer, but you didn't ask it correctly. No. You're just going through the questions. You need to learn how to take multiple choice questions. Those of you, by the way, who are going into nursing or rad tech, going to be psychologists, you have to pass a board exam to get your license. It's all multiple choice questions. Okay? And I'm going to show you another question that's even harder than this one, that I would say the majority of the questions on the nursing board are application questions. All right, you got this? Come on, let's make your selections. All right, you can talk with the person next to you. Let's just get this one done. Ready? 1, 2, 3. All right, that's good. What does that say? 37%? Is that? 37%. That's almost exactly what it was the other day, so I guess I didn't explain it better today. I thought I did. Correct answer is cerebral cortex. When I covered that slide with that weird guy and I said, it's the cerebral hemispheres that are there, I said, what we look at is the cerebral hemispheres, the right and left. It's the cerebral cortex, also known as the cerebellum. Okay? So if you got this one wrong, that's okay, because if it's on your test now, everybody will get it right. Right? All the different portions. The cerebrum is just one small part of the brain. The corpus callosum is just a little connecting tissue that's there. The forebrain might be a good answer because it's this part, but it's really the whole wrinkled layer of all that gray matter that's there. That whole area is called the cerebral cortex. All right. Ooh, now here's a tough one. This is called an application question. This one you might want to talk to others about. When you take your nursing exams, you don't talk to anybody else. You're in a little room with a computer. If a split brain subject, so right away stop. This is how you do application question. What's a split brain subject? Someone who what? Someone who's had their corpus callosum cut. Okay? So now I'm thinking, someone who's had their corpus callosum cut. If they were given a key, but they couldn't see it, so they're just looking like this, given a key, and they put it in the person's left hand, right? So here we go. Someone who's had their corpus callosum cut, they've got a key in their left hand. Got it? Key in your left hand. Everything we talked about, you now have to apply, application question, apply to come out with the correct answer. This person could easily name what he had touched. 2, would be unable to describe the object. 3, would be able to point to the key with his right hand, or would have to wait for the information transfer to take place before describing it. There's only one answer. But in order to answer this, you have to pull together everything I talked about in terms of split brain research. So good, you can talk with the people next to you. This is a little mystery. All the information I gave you. All right, we got this? You don't get it by now. Just guess. All right, we've got 80 people. All right, 82, 83. Once, twice. All right, here we go. Let's see what we got. 58% of the people said 2. You're right. All right, so let's go through this. Could easily name what he had touched. No. The key is in his left hand. All right, that information goes to the right brain. The center of speech is in the left brain. So he's not able to say what it is. All right, because he's got his gut. Would be unable to describe the object. Yeah, that's true. Couldn't describe. In fact, they've done this experiment, and people have had their corpus callosum, and they say, "Well, what's in your hand there?" And they know something is there somewhere, but they just can't say it because that's the center of speech is over here. Would be able to point to the key with his right hand? No, because the right hand is controlled by the left brain. The left brain doesn't know what's going on because it's all going to the right brain. Would have to wait for the information transfer to take place? No, the corpus callosum was cut. It can't transfer information. Right? Tough question, right? But these are called application questions. And when you take your rad tech exam, your nursing boards, these are the questions you're going to have, okay? Which, as your future patient, I would rather have you know how to apply what you learned in your life rather than you saying, I know the answer to that because I memorized that in a book. No, this is my body. You can't memorize. You have to know how to apply this in your life. All right, that's the end of that chapter. So I am going to start in the next 15 minutes. The next chapter, and the next chapter is about babies. Is all about human development. This chapter, we're going to talk about how you got to be who you are and the changes you made in your lives physically, emotionally, socially, and cognitively. Those of you who in your programs, you might have to take another psychology course. It's called Psyc 2314, Lifespan and Development. This is Lifespan and Development. So they'll take this course and expand it. It's all about how you have changed over a lifetime. All right, so there are all these cute little babies. All right, so the first thing we want to talk about is the classic argument in psychology, which is how did you get to be who you are? What has more influence on you, nature or nurture? Nature being hereditary aspects, biological aspects, okay? Nurture being the effect of the environment. When I sat where you were in Introduction to Psych class, what? Get out of there. Boy, we had a whole day discussing this because there weren't any real clear-cut answers to this. Nowadays, I would say it's neither, but both. You catch that? How do we get to be who we are? Biopsychosocial. It's a combination of nature and nurture. Combination of the two. Genetic predispositions, hormones, brain structure, conditioning, modeling. Remember all that? That's what it is. So let's talk about you. Did you know that babies are born with certain temperaments? Those of you who have a few children can say, oh yeah, you were my active baby. You were my good baby. You were difficult. Okay? Because babies were born with certain temperaments. That's their core of their personality. And what happens, certain temperaments have to do with how sensitive they are to the environment, how much energy they have, and their various moods. Researchers have shown us that there are different types of babies when they're born. One type is called the difficult baby. And I hope none of you get a baby that's difficult. Because if this is your first baby, you probably will never have another child. Okay? Difficult babies make up only about 10% of all babies, but they are highly sensitive to their environment. You go, hello, baby. Ah! They cry. Okay? It's hard to get them to sleep. You rock them and rock them and rock them and rock them and rock them, rock them, and you put them down on their back, and they're sound asleep, and you take one step, and the floor goes, and they go, ah, and they wake up. They're like, oh gosh. They're sensory sensitive. You feed them, and if they don't like the texture of the food, they'll spit it out or cry. If they don't like the smell of food, the texture of the food, they're picky eaters. And their mood is always anxiety producing for you, but they're always stressful. It's very, very hard to calm these babies down. Okay? They're called difficult babies. We used to call them colicky babies as well, because one of the things we find is that they don't seem to have a well-developed intestinal system, and what happens is they're upset. Their stomach is upset, so they're always kind of cranky. But it may also be cause of brain development as well. But we call them difficult babies. Most of you will have what's called an easy baby. 40-something% of all babies born are easy babies. Thankfully, otherwise no one would be having a second child. Easy babies. All right, it's time to go to bed. Okay. Why do this? Just put them down, right? And they fall asleep. You play loud music in the house. You walk by their bed. You say, hey, look, the baby's sleeping. Come on over. Let's watch him sleep. They are not sensitive whatsoever. They're very mellow babies. They defecate all in their diaper. They go so much that it's leaking out of the side of their diapers. They wake up and they just go, And you go, what's going on? You go in there and they smile at you. Oh, they put their hands in it. It's all over them. It's no big thing. Life is easy, right? The difficult baby, as soon as they urinate, it's too cold. It's by my skin. Somebody take it off. Very, very sensitive. The next baby are called slow to warm up babies. Okay, and they make somewhere in the low 20s, the high teen percentage of babies. These are also called shy babies. Okay? Sometimes we call them one-parent babies or one-mother babies. They attach themselves to the mother, and they don't want to be with anybody else. Okay? Grandma, who has had 27 grandchildren, who's the proverbial Mother Earth, everybody loves her, picks up your baby, and the baby does this. Oh, don't touch me. And they start crying, and as soon as you pick them up, they snuggle into you and kind of look at like, I don't know who you are, don't touch me. I only want to be with my mom. It's just they're very, very, very shy babies. It looks like babies are either have these three distinctive qualities or the other percentages have combinations of them. Mostly difficult, but a little shy. Mostly shy, but a little difficult. Okay? Usually don't get a difficult, easy baby. That's kind of a weird combination, but combinations that are there. Now, do they outgrow this? Yeah, they eventually outgrow it. It really depends on, now that's the bio part, the psychological and environmental part, psychosocial, would be how the parents match up, real quickly. If you have a shy baby, your baby's shy, but you're born to two extroverted, go-getting parents, and the family's getting together on Sunday, and your little 3-year-old child is kind of like, oh, I'm kind of shy. You say, no, you shouldn't be shy. You need to be just like mom and dad. What we're going to do, you learned that song in preschool the other day, and when we get to the family party, you're going to stand up before everybody and sing that song. No, Mom, I don't want to do that. Please don't do it. No, you're going to do that. Well, what does it do? Just create more anxiety for that child. So that child may be born slow to warm up and born as shy and be really shy. Because all that anxiety going, you keep pushing them. Or the mother, father who matches up to the baby who says, yeah, well, that's okay. That's just who you are. You were born that way. But you know what? It would be really nice if you could sing that song that's there. But if you don't want to, that's okay. But maybe you and I can do it together. Because you know what? Everybody gets nervous when they're in front of other people. Really, Mama? Yeah, you do too? Yeah, even I do. Oh, really? What does that say? My feelings that I have are normal. It's okay. And then let me progressively get you more comfortable doing this. And then they will probably always have a tendency to be shy, but not as shy as the other one. You get that?